All right, for number one, to solve it, we have to first train our brains to say, well, what are we getting by itself? And we're getting that x all alone. Well, the first thing we always need to do is say, what's on the same side as the x? Well, there's a 3 and there's a -9. So we have to decide which one to get rid of first. Well, this 3 is written right next to the x. That means it is multiplying the x. So I'm going to write that little m above it so I can remember it's multiplying. The -9 is subtracting from the x. So I'm going to write a little s above it so I remember it's subtracting. Now, when we're solving it, we are doing the reverse order of operations, which means we start down here at the bottom. So we are looking for anything that's being added or subtracted first, and that's what we have to get rid of. Well, since the 9 is being subtracted, we have to get rid of him first. And the opposite of subtracting 9 would be to add 9 to both sides. So I bring down my 3x, I bring down my equal sign, and 3 plus 9 is 12. Now again, we cannot stop until the x is all by itself. The only thing that's on the same side as the x is the 3. The opposite of multiplying by 3 is dividing by 3. So I get x equals 4. First thing we would do on number 2 is distribute a property. -4 times x is -4x. -4 times -3, negative times negative is +12. And then I bring down my equals -8. From here, this -4 is multiplying the x because it's written right next to it. Whenever they're written right next to each other, that means multiplying. And the 12 is adding on to the x. And again, we have to get rid of anything that's being added or subtracted first. So that's why I have to get rid of the adding 12 by subtracting 12 to both sides. So I bring down my -4x, and on the left or the right hand side, I get -20. My last step to get rid of the -4, it's multiplying the x. The opposite of multiplying by -4 would be to divide both sides by -4, and we get x to equal +5. Number 3, to solve this one, I see the distributive property on the right-hand side. So on the left-hand side, I'm just going to bring all this stuff down because I'm not going to do anything with it yet. But on the right-hand side, 2 times 5x is 10x. And then 2 times -2 is -4. Now right here, I'm hoping you guys would see something kind of weird. I have a positive 10x on the left-hand side and a positive 10x on the right-hand side. Those are the exact same things. That means our answer should be either infinite many solutions or no solutions. So I'm going to keep going and solve this. Now, when I have like terms with variables on both sides, I like to bring the smaller variable to the larger one. So since they're both the same, there is no smaller or larger, so it doesn't matter which one I bring over. So I'm just going to bring over the opposite of positive 10x is -10x. And then all my 10 and x's cancel out. There are no more x's, there's no more 10s, so you cannot write an x anymore. I'm going to bring down on the left side, all I have is a +4. And on the right side, all I have is a -4. Well, this is not my answer, but it does tell me what my answer is. 4 does not equal -4. That is a false statement. So my answer is no solutions. Number 4, literal equations. This is the same thing we've been doing. Upside down t's, getting whatever variable they want by itself. Well, on number 4, they're saying solve for the x. So we have to get the x all by itself. So again, train your brain and say, well, what's on the same side as the x? Well, there's an a written right next to the x. That means that a is multiplying the x. Well, then there's a b over here that's being added on to the x. So right above that b, I'm going to put a for adding. Now, according to the reverse order of operations, if I'm going to get that x all by itself, I have to get rid of anything that's being added or subtracted first. So when I look over here, between the a and the b, I have to get rid of that b first. So I simply ask myself, what's the opposite of adding b? So I subtract b from both sides. Well, on the left-hand side, I'm going to bring down my a times x. And on the right-hand side, it says c minus b. Well, those are not like terms. I can't put them together. And that subtraction problem, I don't know what the answer is. C minus b, it could equal anything in the world. So I'm just going to leave it the way it is and write c minus b on the right-hand side. Now I have to keep going to get the x by itself. The only thing that's still on the same side as the x is this a right here. And that a is written right next to the x, which means multiplying. So I have to get rid of multiplying by a, which would be dividing everything by a. On the left, my a's cancel out. I bring my x straight down. But on the right, I have a fraction c minus b over a. Well, we always want to reduce fractions, except this one doesn't reduce. So since it doesn't reduce, I'm just going to leave it the way it is, c minus b all divided by a. The x is all by itself like they want, so we're done. All right, number 5, we are solving for the a. So again, train your brains to say, well, if I'm getting the a by itself, what's on the same side as the a? Well, there's a b and a y. Well, the b is dividing the a. So I'm going to write d right here beside it so I don't forget that that b is dividing. The y is subtracting from it. So I'm going to write a little s above it so I don't forget that the y is subtracting. Well, according to our reverse order of operations, I have to get rid of anything that's being added or subtracted first. So on this one, I have to get rid of the subtracting y. And to get rid of subtracting y, we have to add y. So on the left-hand side, I have a being divided by b equals d plus y. Now again, we have to keep going until we get the a all by itself. The only thing that's on the same side as the a is the b, and the opposite of dividing by b is multiplying by b. Okay. Now, there's two ways of writing our answer, and I'm going to try to show you both of them, one in purple and one in orange. The purple, I can take both of them and multiply by b. So d times b would be db, plus y times b would be yb. So if I multiplied both of them by b, that would be my answer. The second way is to use parentheses. I'm going to put b on the outside, and I'm going to say I'm going to multiply him by d plus y using parentheses. By writing it like that, I am showing that I should take the b times both the d and the y. So both of these answers are completely acceptable. The purple one probably looks easier to you though. Number 6, to get the b by itself, because we are solving for the b, we have to ask ourselves what's on the same side, an a and a c. Well, both of them are written right next to the b value, which means they are multiplying. The opposite of multiplying by a and c is dividing by a and c. On the right-hand side, my a's and c's cancel each other out. So I bring down on the right-hand side my b all by itself. On the left-hand side, that's a fraction, and we always want to reduce fractions, except this one doesn't reduce. So I'm just going to bring it down the way it is, d divided by ac. The variable we wanted by itself is alone, so we're done. On number 7, again, we just have to ask ourselves, what variable are we trying to get by itself? Well, it says to solve for the h. So then we ask ourselves, well, what's on the same side as the h? There's an L and a W. Now, they're all written right next to each other, which means they're all multiplying each other. So then, if I'm trying to get the h by itself, and it's getting multiplied by L and W, I would simply say, what's the opposite of multiplying by L and W? Which is dividing by L and W. Well, on the right-hand side, my L's and W's cancel out. I bring my h equals straight down. And on the left-hand side, that's a fraction. We normally reduce fractions, except this one doesn't reduce. So I have volume being divided by length times width. All right, on number 8, we are trying to get the x all by itself. Well, it's getting multiplied by a 1/2, and it's getting multiplied by a y. Now, on problem 6 and 7, when they were getting multiplied by two things, I would simply say the opposite of multiplying by those two things is dividing by those two things. This is kind of an exception because the two things that's getting multiplied, one of them is a fraction. So that's why I'm going to handle this one a little bit differently. So rather than doing one upside down t and getting rid of both of them, I'm going to do two separate upside down t's and get rid of them separately. And I'm going to start with a fraction. Now, the other day, we learned the opposite of multiplying by a fraction is not dividing. It has a special rule. The opposite of multiplying by a fraction is multiplying by its reciprocal, which is, in this case, 2/1, or just 2. So on the left-hand side, my fractions cancel out. I have x times y equals, and it's z times 2. Now, do not write your answer as z2. The coefficient goes in front. So when we write this, we write 2z. And again, pay attention to the fact that I wrote that line through my z. That way it does not look like a 2. You know it's a z. That's a habit you would need to get into also. All right, now from here we got to keep going to get our x by itself. The only thing that's on the same side as my x is the y. Since it's written right next to it, it's multiplying. The opposite of multiplying by y is dividing by y. So on the left-hand side, I get the x all by itself equals. On the right-hand side, again, I have a fraction, and this one doesn't reduce either. So I'm just going to bring it down. 2 times z divided by y. Number 9, to get the c by itself, we have to say that there's a variable d on the same side and a y. This d is dividing, so I'm going to put a d right there beside it. The y is actually adding. And according to our reverse order of operations, we have to get rid of anything that's being added or subtracted first, so I'm going to get rid of the y. The opposite of adding y is subtracting y. So I have c divided by d on the left-hand side, and on the right hand, I have g minus y. Keep going until I get the c all by itself. The opposite of multiplying by d, or I'm sorry, dividing by d is multiplying by d. And again, there's two ways you can write this like earlier. I can do it where I multiply both of them by d, so I could say g times d minus y times d. Or I could just say d times both of them, showing the parentheses. Either one of these is perfectly fine for an answer. All right, number 10 is almost exactly like 6, 7, and 8. We have to get the variable that they want us to get all by itself. So we are trying to solve for the r right here. So we simply ask ourselves, to get the r by itself, there's a 2 and a pi that's written right next to it, which means multiplying. How do we get rid of multiplying by 2 pi? Well, we divide by 2 pi. So now we have on the right-hand side the r all by itself, and on the left-hand side, c divided by 2 pi, and we're done. All right, on number 10, we are trying to get the t all by itself. Well, there's an r right next to it. The r is multiplying. So what's the opposite of multiplying by r? Dividing by r. So I get the t all by itself equals distance divided by the rate. Number 12, to get rid of, or to get the h all by itself, we have to get rid of the 1/3 and the b, and since they're all written right next to each other, that means they're all multiplying. Normally I would say, what's the opposite of multiplying by 1/3 b? And you would say dividing by 1/3 b, except fractions have a special rule. So I'm going to get rid of it first by itself. And the opposite of multiplying by a fraction is to multiply by its reciprocal. So 3 times v is written as 3v. Do not write v3. And I'm going to bring down my bh on the right-hand side. The last step to getting the h all by itself, well, there's a variable b on the same side. That's multiplying. So I'm going to divide by b, and I get h equals 3v divided by b. All right, number 13, just like number 12, the opposite of multiplying by 4/3 and r cubed would be dividing by 4/3 r cubed, except fractions have special rules. So rather than getting rid of both of them at the same time, I'm going to get rid of them one at a time, the fraction first. The opposite of multiplying by a fraction is multiplying by its reciprocal. So on the left-hand side, I have 3/4v equals pi r cubed. Now again, we're trying to get the pi symbol all by itself. Well, it's written right next to an r cubed, which means multiplying. The opposite of multiplying by r cubed would be dividing by r cubed. And for purposes of this class, I'm going to allow you to leave your answer just like that. Okay? So if you want to put 3/4v divided by r to the third, I will let you leave it like that and you will get credit. Number 14, we're trying to get the h by itself. It's getting multiplied by a parentheses and a 1/2. I'm going to get rid of the fraction first. The opposite of multiplying by a fraction is to multiply by its reciprocal. So I get 2 times a, which is written as 2a, equals, and I'm going to bring over the entire right-hand side. Bring it straight down. Now from here, we're trying to get the h all by itself. It's getting multiplied by everything in the parentheses. Well, the opposite of multiplying by everything inside the parentheses is dividing by everything inside the parentheses. And I'm going to do that to both sides. On the right-hand side, they cancel out, leaves my h all by itself. On the left-hand side, it's a fraction that doesn't reduce, so I'm just going to bring it straight down. Number 16, we're trying to get the a by itself. Well, do you guys see an invisible -1 written right in front of it? That means multiplying. Then there's a 3z that's positive, and since it's positive, that actually means it's adding. And we have to get rid of anything that's being added or subtracted first. So I have to get rid of the 3z. And the opposite of positive 3z or adding 3z would be subtracting it. So on the left-hand side, I have -1a, and I wrote the -1 there so you guys can see it so it's no longer invisible, equals, and on the right-hand side, I have r minus 3z. Well, now all I have to do to get the a by itself is the opposite of multiplying by -1 is dividing by -1. So on the left-hand side, my -1's cancel. On the right-hand side, we have a fraction. So far, our fractions have not been able to reduce. This one can. We can divide by -1. Positive r divided by -1 is -r. Negative 3z divided by -1, well, negative divided by negative is positive. So that's positive 3z. And we have our a by itself, so we're done.